high levels of prolactin. Treatments for hyperprolactemia spawn as dopamine agonists known as cabergoline.
Let's get to spawn.
Cabergoline. The role of a general dopamine agonist is to impersonate or enhance the effects of a neurotransmitter's action. Dopamine is known. Oh yeah, go to slide 3. Yeah, see that's what I fucked up on. Actually, no, stay on slide 3. Dopamine is known as a level-controlled prolactin. The dopamine agonist prevents dopamine from entering a presynaptic cell, thus more dopamine is left to attach to a postsynaptic cell. It has the ability to lower prolactin levels through agonistic effects on the D2 receptor in the anterior pituitary lactotroph cells located in the pituitary gland, therefore balancing prolactin levels that will gain proper cognitive function. Oh yeah, that's what I fucked up on. See, I should have transferred the slide. Okay. Yeah. Okay, whatever. I'll go. Just take a look at level slide 4. I'm just gonna
Level.
You see the map there? I'm gonna
Yeah.
be like, these are the tablets, and this is the map. This is literally a flowchart. The more prolactin you have, the more dopamine you need to inhibit this hormone. To inhibit prolactin synthesis.
But why?
Honestly, I wanted to go into that, but there's so much research. It just goes away from the
you don't want to bad enough.
Yeah,
I'm gonna lose marks if I go into it.
Okay, you know what, fine.
So look at the synthesis, bro. It's gonna be hard. Okay. So we start with compound 1. I'm not gonna say the compound because it's really long.
Please say it. I don't know. I can't read it, bro.
Shut the fuck up. The first one. We're gonna start with this compound, and I will say it's compound 1. And this suffers a nucleophilic attack from the dimethylpropane diamine, where the 2-hydroxypyridine takes a hydrogen from the nitrogen, while the ether group is protonated, making it a good leaving group. The compound made from this reaction is the second molecule shown. The diterbutyl decarbonate is then added and then goes through a nucleophilic attack again from the nitrogen at the 4-membered ring. The hydrogen connected to the nitrogen is removed by the now terbutyl hydrogen carbonate ion. This process creates our third compound.
Can you get any more boring?
Yeah, this whole thing is boring.
Say it with your chest on.
The lone pairs. Okay, shut up.
Nigga, that's saying of your chromosome.
No. The lone pairs of the nitrogen adjacent to the 6-membered ring processes a nucleophilic attack on the phenyl chloride.
But this got left.
Oh wait, is it? Okay, on the phenyl carbon chloridate. While the nitrogen is also deprotonated by the sodium bis trimethylsilyamide. This process produces our 4th compound, but if whoa, holy fuck! This is just I fucked up on. See, I lost myself. I low-key lost myself.
It's okay.
Yeah, our 4th compound. An ethanamine is inserted for the lone pairs to attack the ketone attached to the phenyl, and the ethamine is then deprotonated by the 2-propanol in order to make the protonated ether phenyl a better leaving group. This process produces our 6th compound, which we want to produce cabergoline, but although this, we could also produce that 5th compound, if the ethamine were to attack the ketone attached to the 6-membered ring. So yeah. Furthermore, with our 6th compound, the lone pairs. See, I fucked up. For the lone pairs. Oh yeah. Furthermore, the 6th compound has its lone pairs of the nitrogen attached to the 4-membered ring, which is protonated by the water, while the OH ion attacks the adjacent ketone. This reaction then makes this group detach from the bigger molecule in order to produce cabergoline. And yeah. I don't know how to make it like sound like the sentence. And this, okay, finally, to finally produce Cabergoline. Okay, you know what? That's it.
That's it.
Don't rate it on entertainment wise. Just rate it on information wise.
That was
Okay,
my
so
entertainment. That was fucking terrible.
I know.
okay, so you've heard that the presentation goes fine, but it's like the questions they ask you
Yeah, I
are
know. I
really
know. That's what I'm
specific.
scared of.
Okay,
That's why I'm bringing the reaction sheet with me.
okay, yo. So look, go to slide 5. I'm gonna ask you something simple.
Okay.
Let me just gauge you right now. Let me just gauge you.
Yeah, I'm twisting my brain right now.
Okay, so on slide 5.
Mm-hmm.
So can you describe again what happens going from the starting compound to the next step? When you add the
Oh, okay. I thought you were gonna fucking make me do this whole thing again.
no, are you dumb?
Okay.
Okay, no, okay, hurry up, hurry up, hurry up. Like so,
Okay.
when you add this tri-substituted amine under 2-hydroxypyridine and 110 degrees Celsius, what happens when that happens?
What happens when that
Like
happens?
what happens in the first step, basically?
Okay, the dimethyl propane diamine um suffers a nucleophilic attack from the no, it doesn't. The lone pairs of the dimethyl propane diamine uh does a nucleophilic attack by attaching to the carbon ketone attached to the one, two, three, four, five, the fifth five-membered ring at the top, and then the um 2-hydroxypyridine then protonated, no deprotonated, and thus making it a making the ether at the top a better leaving group to produce our second molecule.
Okay, holy fuck. First of all, are you literally reading off a piece of paper?
No, no, that I literally just looked at my reaction.
No, like in the beginning, like when you were going
Oh,
through
the
the
beginning, yeah, I read it from the paper. Fuck that, I'm
straight,
not
You
saying this
sound
from
better.
heart.
bro.
Hmm?
No, because you sounded so robotic, and even right now you sound so robotic.
Yeah, like I actually want to like
No,
off
bro.
myself.
Okay, 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 okay. This is my excuse.
What? What?
This is my first time reading what I just wrote. That's
Okay.
why
Anyway.
I'm not confident what I just.
Anyway. Okay. So
Okay.
basically, so just to sum up that giant essay you told me, that amine nucleophilically attacks the carbonyl, and it eliminates
Carbonyl?
the carbonyl.
Is that the same thing as saying the carbon attached to the ketone?
Sure.
Okay, whatever, go on.
Anyway, so the amine nucleophilically attacks the carbonyl carbon and eliminates a methoxide, right?
That's oh yeah, aluminum methoxide.
Yeah. So that happens, right?
Mm-hmm.
So why doesn't okay, so you see in the first molecule, like the starting
Mm-hmm.
molecule, you see how there's like an alkene. You see there's the ring nitrogen, right? You see how there's like a 3-carbon thing sticking out of it with the double bond?
Yeah,
Yeah, why doesn't that just do an intramolecular reaction and attack the carbonyl carbon?
I don't know.
Because
Further
Okay,
research
so
has to happen. Yeah, I know. I don't know. I'm just gonna say that further research has to happen.
okay, no, so the thing I was trying to test you for was that a lot of the times you're not gonna know, but you can't just straight up say that. You have to like work
Yeah,
around it.
you are. You're allowed
No,
to.
that's what I just said. You're allowed to say you don't know, but like you can't just say straight up you don't know. Like at least try to reason with it, like because right now it
Okay,
literally
okay. What
seems
would
like
be what would be the reason though?
because it's just thermodynamically like unfavorable to just do that.
Okay,
When you have amines in solution, it's just better to have amines attack the carbon rather than an alkene. The alkene is better the way it is as opposed to it attacking it. You know what I mean?
okay. Just thermodynamically
Yeah,
favorable.
because it's just like why climb a big hill when you can just take a normal road, right? Like you could go over the hill, but why, right?
Can we also do Markovnikov addition shit?
Yeah,
Where's
with like
Markovnikov? Is that the one that
Mark
that's like
Zucker,
with like alcohols, like pure alcohols and stuff like that. But like right
Mark
now, like
Zuckerberg.
Bubberberg.
Oh my god, bro. Okay, now I'm stressing over. You know, I'm good. Good. I'm stressing over the question.
No, because like, bro, you have to like really understand it, because they're gonna ask you questions and like they're gonna really mark you on that and shit like that. Like, you literally look like you're just memorizing at this point. And I understand a
Further
lot of people.
research has not been done.
Yeah, like what are you gonna say other than further research needs to be done? Because they're not just gonna ask
Your
you one
mom.
question. They're gonna ask you like 3 or 4 at least.
Fuck. Fuck. Ask me psychology questions. I'll know.
Lol. I mean, okay,
No,
fine.
because
Okay, no, actually, I could ask you something. So
no. Okay, go ahead. Go ahead.
okay, so I'm just gonna genuinely ask you. So the final product is the thing at the very end, right? The one
Yeah.
that's like not bolded.
Mm-hmm.
Okay. So that's the what does this do exactly? First of all, what does it do?
It attaches to the D2 receptors of the anterior pituitary lactotroph cells in the pituitary glands. It's
Holy
literally
shit. Dude, you don't have to say the
so
whole thing, bro. You're just
Stop
wait, wait, wait,
rereading
wait,
it,
wait,
man.
go, go,
Stop
go. I'm
fucking
just nitpicking right
rereading
now.
it.
I'm just nitpicking right now, but go on.
okay, fine. I'll say okay, that wasn't even a lot. Shut the fuck up. It was just okay. It was
Anyway,
not that serious. Okay,
anyways.
it attaches to these receptors in the anterior pituitary lactotroph cells in the pituitary gland, where prolactin is formed, right? And attaching to this will inhibit the dopamine to attach to it.
Okay,
Yeah. Therefore, producing more dopamine, and once an excess amount of dopamine occurs,
okay,
the cabergoline will then detach from the D2 receptors, and then more dopamine will be attached to the postsynaptic cell, and
okay,
then therefore lowering prolactin cells.
okay. So you said the cabergoline attaches to the receptor, right?
Yeah,
What part attaches to the receptor exactly?
fuck. I'm not too sure.
No, that's okay. That's okay.
I know. I'm saying I'm not too sure because
No,
that
that's
really
okay.
goes into no. Let me say my answer. I'm not too sure about that, but that really goes into depth of psychology.
No,
But
that's
I will
that's still
find.
that's still a chemistry question. No, 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 no. You
I
didn't.
know.
No, no. The thing is, I needed to know that to ask the next question, but it's okay because that wasn't part of the real question. Um. Okay, so basically, like, I'm gonna just ask you anyway. So you know the step before it to make this molecule.
Say again.
Okay, you know the cabergoline.
Yeah.
You know the thing that becomes it, the thing right before it.
Yeah.
Why can't you? What if I stop the reaction before it became a product? What if I stop the reaction before adding in HCl, water, and putting it to 80 degrees Celsius? What if I use that instead? What would happen?
What do you mean? You're just stopping it?
What if I just stopped it right before it became the cabergoline? The final. What if I use the final intermediate as a medicine? What do you think would happen?
Well,
It
you wouldn't
dies.
have Cabergoline. um, if you just stopped it
Basically, what I'm asking you is, what's the difference between cabergoline and the thing right before it?
right before it.
Yeah, look at cabergoline and look at the arrow, HCl, H2O, 80 degrees Celsius.
Okay.
The thing right next to the arrow, N5R, 8R, 10R, 6-allylargolin.
Oh, what would happen if I just stopped it right there?
Basically, like, what's the difference between cabergoline and 5R, 8R, 10R?
Oh, there's a. Uh, they differ by the. You see the the butyl. Okay, I forgot what that was called. Honestly,
Okay, whatever, just go along.
no, yeah, they differ by that the nitrogen group in the four-membered ring at the bottom. You see, there's no more BOC. There's just an H. So that's what differs that compound to cabergoline.
Uh,
Okay, I don't fucking know what to say.
well, yeah, that,
Yeah,
but like, look at the fourth ring. Look at the fourth ring.
Oh,
Let's
can you
see,
say
like, look at the fourth ring. You see how the configuration there is R, but in cabergoline it's S, right?
oh, good point,
Because you want to know why that's important?
yeah, because okay, you say I have an idea, you say yours. No,
Okay, so
wait,
basically, because this is something they can ask you, right? Because the
wait,
reason why I'm
before you
asking,
finish, the final one is S, right?
yeah,
Okay,
the reason why I'm asking you is because this is something they can ask you, right? Because the whole point of like the way proteins and enzymes work is that if you were to use, because the question I asked you was, what if you just stopped the reaction and used the last intermediate? What if you use that? The answer would be that nothing would happen. Your body can't use that because the whole reason of getting this final product is because the protein, the D2 receptor, only interacts with S molecules, like S configurations. If it was R, it wouldn't interact with it. You know what I mean?
I actually didn't even know that.
No, yeah, like, cause like thing is like, it's just like with cocaine, like, or like, no, it's not cocaine. I'm the boosting. This is other drug, right? It's like the R, the R version of the drug is lethal, but the S version doesn't do anything. You can just drink it in your chocolate milk, nothing will happen. But the R version will kill you.
What S version?
What?
Okay, say it again. Like I was paying attention, but I didn't
Okay,
know
so
it.
basically, proteins and enzymes interact with molecules to, do things, right? Like you
Right.
said, D2 receptor interacts with cabergoline and it releases dopamine, right?
Mm-hmm.
That means this protein shows biological activity when it interacts with cabergoline, right?
Mm-hmm.
But only a specific type of cabergoline because proteins and enzymes are very, very, very specific. If it's not the right
The regional
configuration,
specific, right?
yeah, exactly. They're extremely region specific. Like if it's not the exact one, they're not going to interact with it. So my point is, cabergoline is in an S configuration. It only D2 will likely only react with the S. If you use the R, which is the one right before it, it won't react. If you were to ingest 5R, 8R, 10R, nothing would happen.
Okay, that's a good point. But why do enzymes and proteins only react with S? Oh yeah, because it's regional specific.
Yeah, it's
Okay,
region
yeah,
specific.
get it.
And like
Yeah, but why S though? Why S though,
no, no,
actually?
like no, because like that's what like that's what the
They just what
experiment.
they like?
No, no, no. That's what the experiment found. That's what the experiment found.
Okay.
Like why go the extra step? Like yeah, like the step also removed the BOC, but like the BOC is like you would have removed that anyway. But like why go the extra step of converting it to the S form? Because they found in their experiment that D2 likes to react with the S form, right?
Mm-hmm. Yeah, I get it.
Mm-hmm.
Yeah, like there's no way you can calculate this. It's just you just have to use experiments to figure this out. There's no way you can calculate it. So
Okay.
that's why like if I were like Jackie and I said like, hey, what if we stopped the reaction right before it became the S form? What if we used the R form? What would happen? You would say, oh, it wouldn't show biological activity. It would just be
Yeah.
inert, or it might be toxic to our body. We can't. It might be
Okay. So
poisonous.
try to say it. So if it was the R version, it wouldn't react with the D2 receptor because our body are only biologically to are the enzymes and proteins in our body are biologically really region specific. So we wouldn't know what would happen. So that's why we try to perform to
Oral sex.
produce the S version of it.
No, we do
So it
know
could
what's in.
actually
No, no. Because
attach.
the thing is, no, you're right for the most part, but like we do know what the enzyme was because we did an experiment. We got the R and the S version. We gave a rat the R version. The rat didn't do anything, but we gave the rat the S version, and the rat did something. So we know that the S version does something.
Okay,
That's
I can't say that because I need specific. I need
okay, but like you know what I
specific.
mean. You know what I
Yeah, I
mean,
get
right?
it.
Like
Okay, let me say it again. So we produce the S version because our D2 receptors in our bodies only okay, not even D2 receptors. Okay, let me get. We produce the S version because the enzymes and proteins in our bodies are really region specific, thus only reacting with the S version to produce symptoms, not
oh
even
yeah, yeah,
symptoms.
like just any it's a
No,
generate a
no, to
reaction.
produce biological activity.
Yeah, yeah, basically. And
Okay,
that's
what
not the
the
rule of thumb, right? Like some proteins like R and hate S. Some
most
like
of our enzymes and okay, wait, the D2 receptors are those classified as enzymes?
yeah, like all proteins. Well, not all, but like most proteins are like enzymes.
Most receptors?
Yeah, okay. All receptors are enzymes.
Okay, because I get it, because like it's like a lock and key.
Yeah, basically, if something does something in the body, it's a protein. No, no, okay. No, if a protein does something in the body, it's an enzyme. If it does something, it's an enzyme. That's it.
Okay, you know, you got me there, buddy. Okay, um how about the fucking the temperatures. How do I explain this?
Well,
I'll be like,
just say like, if you didn't use heat, it would take you 100 billion years before you get the product.
just
No,
say
I'm
that.
not even joking. You can put in all the ingredients, but if you don't add heat, it will take you
Can
exactly.
I say steric hindrance?
No, pal. I mean, sure. Like it, there's too much. Yeah. Okay. Fine. 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 There's too much steric hindrance. There's too many bulky groups. The molecule is just way too big in general. Like the reaction is very, very slow naturally.
Because okay, from the first product, when that dimethyl propane diamine reacts with the carbon ketone, how do you say carbonyl ketone?
Yeah.
Carbonara.
Whatever. Sure.
Carbonyl ketone.
Yeah.
Is that area really sterically hindered?
In this case, sure, but mainly it's just that nitrogen is really nucleophilic and the carbonyl carbon is really electrophilic.
Okay, that's a good one.
Yeah, because like right now it's not a steric hindrance thing. It's just more like one is nucleophilic and one is electrophilic. They're gonna interact. You get it?
Yeah, I get it. Really electrophilic and nucleophilic.
Disgusting.
No, that was wrong.
Fuck Tetris, man. Fuck this game.
What other questions can you ask me?
I mean, I don't know. Like, you want me to ask?
Yeah, just go for it at this point.
Okay.
Alright, Cub.
Yeah.
What's your mom's body count?
Wow. How about your mom?
Oh no.
Oh my god. Okay.
Here you go, deadass. Just ask me a question. Wow.
Okay. Okay, so in the first step, I'm gonna ask you something easy. In the first step, what is 2-hydroxypyridine doing?
2-hydroxypyridine. So that's literally the base solvent, and its job is to deprotonate the nitrogen attached to the ketone. Deprotonate the dimethyl propane diamine that was then attached to the ketone carbon,
Okay.
and thus making it just making the carbon the ether methyl a better leaving group.
Okay, perfect. There you go. Finally, good answer. Genuinely good answer.
Is it called a carbon ether? Methyl ether.
Yeah, but yeah, exactly.
Let's see it
Okay, and why is it at 110 degrees Celsius?
for your mom.
Oh.
When you put heat, bro. That's what I was asking though. I was asking. That's what
Okay,
I was
basically,
asking
okay,
you.
look, like they're huge ass groups. Like
Oh,
they're huge ass groups, and thing is, this reaction in general would take long, so you need to add heat to like make it go faster.
okay. So I'm gonna. I would say.
Just
So
kinetics. Just
basically,
say it's to improve the kinetics. That's it.
to improve the kinetics, like
Yeah, just to make it go
the
faster.
yeah. Wait. Let me say. It's literally just to improve the kinetics, right? So
Yeah.
like the carbon ketone is really electrophilic, and the dimethyl propane diamine is really nucleophilic, right?
Yeah.
But to get to that location, this is a really big molecule we're talking about. So
Oh wait, I just figured something
yeah,
out. I'm gonna ask you a really good question next. Go on.
this is a really big molecule too. Uh, really big molecule we're talking about. So like to find that location around the molecule would take a long time. So
Exactly.
we increase
Exactly.
so we increase the temperature to like put energy into the whole system for it to find the location
Exactly.
faster.
Exactly. Okay, moving on. Okay, good. Good answer. Okay, now secondly, you use 110 degrees Celsius in the first step. Okay. But then in the second step, you use 50 degrees Celsius. Why? Why can't you still stay at 110 degrees Celsius? It makes the
Because it's
reaction go
hot.
faster, right?
For 50 degrees Celsius.
Yeah, like why not use 110 degrees Celsius? I mean, you wanted to go faster, right?
You might burn the molecules.
You know what? You're that's the right. Yeah, but Jose, were you gonna say that?
To be honest,
TBH honest.
hold up.
Yo, if I get this answer, oh, okay, yeah, Gub, you owe me your life.
You don't want to burn the molecules. Well,
You're gonna burn the fucking molecules, bro. They gotta live too, you know.
Omelette.
Bro, I'm not even sure because the molecule's already really it just got bigger. So what the fuck do we use? Okay, you know I'm gonna look at the research paper.
Maybe
No,
the
no,
heat
no,
to
no, no,
shrink
no,
it.
no, bro. Don't overthink it. Don't overthink it. Don't overthink it.
Okay, fine.
Okay, you know what? I'll
Wait. Let me try. Let me try now. Let me try.
do you want a hint? You want a master in physics hint?
No, hold up. Don't fucking spoil it for me. I'll cry.
Oh, no, I meant to say master in chem. Master in chem.
The ethanamine. So again, the ethanamine is really nucleophilic, while that carbon ketone is also electrophilic. But we need this 50 degrees. We don't need as much heat since. Okay, give me a tip. Give me a tip.
Okay, so in the first step, what did you add? What was the solvent?
Uh, pi-
I'd like to answer the question.
hydroxypyridine.
I'd like
Okay,
to answer the question.
what?
There may be a boiling temperature, boiling
Oh my.
point into the molecule.
Okay, well,
Oh, bro, you're fucking right.
well,
Well, Anson's just
okay, well,
Anson
Anson, why don't you transfer an UTSC?
just
Okay, you know what? I'm just gonna give you an answer. You already spoiled this. So basically, THF and DMAP are organic solvents. Their boiling point is like really low. If you put it at 10 degrees, you just boil off all the solvent. You're gonna lose your product. So
okay.
you keep it at 50 degrees just to give it enough heat to keep it going, but you don't want to literally evaporate all the solvent.
Fucking do it. I fucking do it.
No, okay, Anson, how did you actually beat that ass?
No, that's what I mean.
That's
Like
amazing.
don't,
What the
don't, no, just,
I mean, it's kind of common sense.
yeah, that's what I mean. Like, don't overthink it. Like, a lot of chemistry is
Like, think about it. When you boil water, like when you boil a kettle in the
Okay,
water,
shut up,
it
I get
evaporates.
it.
No,
Just
you don't get
come.
it. No, Anson, give it the whole explanation. Don't give it the end result.
Go.
I
Send
get it.
this to me,
Shut
yeah?
up. No,
Just for that, boil a fucking kettle right now. I don't care if your roommates are sleeping.
Okay, keep going, Amber. I'm
Okay,
gonna
well,
say that for every.
yeah. So basically, like, this is something they can genuinely ask because it's
Wait,
like,
DMAP and THF really have a low boiling
yeah,
point?
DMAP and THF are organic solvents. Like, BOC2O is the actual reactant, but DMAP and THF are solvents. You remember in the lab,
No,
you
to be
had,
honest, wait, hold up. I never fucking used DMAP or THF in the
yeah, you did.
reaction.
Yeah, you did.
I
Okay,
didn't.
so
I only use BOC2O.
no, and okay, no, I'm not talking about the paper. I mean in the lab. Like in the
Okay,
lab,
what?
like we used THF before, and DMAP is really similar to like DCM and
But
diethyl
what's the
ether.
point of tetrafluoro?
It's just
Hold on, I
organic
don't know.
solvents. Like you just want to like why use water as a solvent? It's just I don't know. It's just a solvent.
But,
Like
but why though?
okay, well if you're gonna bro, like how do I put it? Like why use a solvent in the first place?
Because we need space.
Well, like you need like a space for the reaction to occur in, right? But like
Yeah.
you don't want to use water in a reaction where you're working with fat. Nothing's gonna react. The fat's gonna keep coming out of solution. Like fat's not water
Is
soluble, right?
okay.
So like with something like this, it's soluble in organic solvents. You want it to like stay in the solution and react. You know what I mean?
Okay.
And this is not something you can calculate. This is just experimentally known. You know what I mean? Like anyway, so THF and DMAP are organic solvents.
So okay.
If you use water in this, it would fuck up the reaction.
You will dilute the process.
Exactly. And plus, water is very like for these things, it's too reactive and it'll fuck up your product.
Gov, give me your chemical privileges.
Genuinely.
Please, I don't even want to be in this court, bro. Because like the water will basically just protonate it, right?
Exactly. Or just, it'll just attack everything.
Okay. Okay. Ask me another question, then answer for me. But it's making me think.
Okay. Well, yeah. So let me see. Hmm. Okay. So
We use HCl and H2O that is higher now to speed up the reaction, but also the melting point. the boiling point has become a little higher due to the solvents being used,
Okay, I'm gonna ask you one more thing.
the reagents
I'm
actually.
gonna ask one more thing. Hmm.
Huh. Huh. Huh.
You know what, Anson? That's gonna keep me up all night. How the fuck did you?
No,
Bro, it's common
yeah, just don't
sense. It's
overthink
literally
it.
common
No,
sense.
no, shut up. I know it's common,
What do you
but
think?
it's
How
like,
did I know
No, no,
that?
think of like Breaking Bad, because bro, those Jesse, you remember Jesse? He was able to
yeah.
like do the meth cook, but like he's retarded. But like a lot of times, a lot of his common sense, like like just follow. It's like a cook. It's like cooking. It's like baking. Like
I'm
bro,
like, nigga,
if
have
you
you
see your
never
cake, if you see
Okay,
your
yo,
cake,
bro.
like
Okay, that's not what's bothering me. Okay, Answer. Just
okay,
get to the
I get it, I
question.
get it, I get it. Anyway, so let me
no? Have you never boiled water before? The fuck's
think.
wrong with you?
Get these
No,
answers.
go
I
boil
want to
some
get
water
these
right now.
questions in my head so I can sleep and dream about these questions.
Yeah, maybe you could learn how to boil water.
Okay, I got a good question. I got a good question. So, in the second the second line, like it's like
Yeah,
this
the
is
second reaction.
the step where you add like NaH, NDS, and Fococcol.
For cockle.
I don't know what this. I don't want to say the.
For cockle. Okay, go
anyways,
on.
so this is not the question, but I'm gonna ask you just so you know, what's the difference between the starting reagent of the second reaction and the product of the first reaction? What's the difference?
Starting reagent of the second reaction.
No, no, no. Yeah, the starting reagent of the second and the product of the first. What's the difference between the two?
Well, as you can see, we have now added buckle.
Yeah, Bach, right?
Yeah, Bach.
And
BLC.
from lab two, what do you remember the Bach does?
Your mom.
Wow.
Well, I'll just go through my thing. The Bach literally just is it actually?
Literally,
Oh, ooh, it activates the nitrogen
No,
group. No, yeah, it protects the nitrogen group.
exactly, it protects it because
Oh, this
because
is so nice. It actually connects
because
because we don't want this specific nitrogen to be reacted with the future reagents being used.
exactly because that nitrogen is really reactive, right? Like you want to
Yeah.
protect it, right? So when you do this reaction, you get this next product, right?
Yep.
hmm
What did Obviously you protected that nitrogen, right? What did you want to selectively react with?
We wanted to get. Hmm.
Basically, what's the difference between the protected thing and the next one?
Oh yeah, I'm looking at that. Basically, we want to react with the nitrogen, close to attached to the carbon ketone,
Basically, the amide nitrogen.
or then amide nitrogen.
Yeah, because if you didn't protect the bottom nitrogen,
It would possibly react with it.
exactly. The whole point of protecting is so you preferentially get the reaction going somewhere else, the place you want it to, right?
Okay, that's a really good point. That's like S tier. But that reaction stuff will probably give me bonus marks because it has to do with the course.
Yeah, well, yeah,
Yeah,
exactly.
it protects the nitrogen.
Yeah, that was like lab two shit. But yeah, anyway, so well, that's it. Okay, now
you're
sleep on
welcome,
it.
Gub.
You know what? Thank you, Amber.
No problem, man.
You know what? You're
I'm
welcome.
surprised you would go through this.
Well,
You're a real friend.
no, I did
Oh,
this
that's
because I have
gay,
nothing
bro.
better to do.
That's so gay.
You know. Your mom's gay.
I actually want to go into it to depth. When does the agonist know when to detach from the receptor?
Because so what happens is that like
Wait. Can I make a theory? Hypothesis.
sure.
So the excess dopamine will eventually kick it out.
Okay, well, yeah, basically.
Okay, that's all.
Well, yeah. So
How
that's
does it
part
kick
of
it
it. That's
out?
part of it. So there's two. Okay. As end result as it could get, there's two outcomes. The excess dopamine literally makes it so that the protein, when it senses all the excess, it just lets go of the
Oh, because there's too much energy.
Well, no, not energy.
Like,
Okay, whatever helps you understand it better. But
I
basically,
mean, okay, there's too much forces literally pushing
yeah, but
the.
yes, it just competitively inhibits it, or like it's a
Oh,
competitor. It's a competitor.
okay.
That, or you could, well, yeah, sure, yeah. For the time being, yeah,
Okay.
sure,
Well,
Yeah.
thanks. I
yeah.
have now got a 4.0. Knock on wood.
Well, I'm so glad I got that recorded. I want to get that journey on video.
Wait, what you got it recorded?
Yeah, it was 35 minutes, bro. I wanted to
Let
get
me
the
see. No, no,
Jesus
no, no.
Christ.
Upload it. Upload it. Upload it.
Oh,
Upload
I love that. Oh, if only. I really hope I got the audio. Hold on.
it.